Alright, let's start this 7.3 lesson with a little review of what we did in section 7.2. In a second, I want you to pause the video, try these two problems on your own, and when you're ready, hit play and you will see the solutions and I'll go through them with you. Okay, here are the correct answers to our warm-up problems. On the left side, I'm using law of cosines to solve for a sine length. 39 degrees and y are my one pair of opposites, so those are the extreme ends of my formula. This is the nice version of law of cosines where the entire right side is filled in and the variable's on the left, so you can just type that whole right side in your calculator. Don't forget to take the square root at the end and you get 8.9. That's the only thing we had to solve for in that triangle was y. On the right, you have a side-side-side triangle, and you're solving, which means you're finding all the angles that are missing. I decided to solve for angle A first. I mentioned in the law of cosines video that you sometimes with this can have a little bit of an issue with law of cosines and then using law of sines afterwards, and kind of some weird cases that can happen with the angles. If you're worried about that happening, my suggestion to you would be solve for always the largest angle first. You are highly less likely to run into any sort of weird special case if you always solve for the larger angle first. And I know here that that's got to be angle A because it's opposite 11, which is my longest side. So you can see 11 and A are my extreme ends of the formula. I simplify a little bit. Be careful in the middle of that formula not to subtract 89 minus 80 because the 80 is attached to the cosine. You need to start moving things away from the cosine, so we subtract 89, divide by negative 80. Inverse cosine gives me my first angle of 114 degrees. Once I know that, A and B, I solve for my next largest angle, become my two pairs of opposites in my law of sines. Set it up, cross multiply, and do an inverse sine to get 42 degrees. Because that's a special case of law of sines, solving for an angle, 42 degrees is the acute answer. If you do 180 minus that, you get 138, which obviously you can see if we already have an angle of 114 degrees, 138 is not going to fit in there, so that is not possible, meaning 42 is the correct answer I'm looking for. Remember here, when you get those two possibilities, only one of them will work if you've already used law of cosines. It's not possible that both of them will work, but you need to figure out which one is reasonable. So 42 degrees here is reasonable, and then once I have A and B, I can just do 180, take away 114, take away 42, and it's going to give me 24 degrees, and I round it to the nearest degree on everything. Here is where these numbers are coming from. And then again, remember at the very end, check that your answer is reasonable. Largest angle opposite longest side, shortest angle opposite shortest side. All right, let's move on to our lesson, 7.3 for the day. 7.3 is going to use our law of sines, law of cosines, and then maybe a couple little extra formulas thrown in to find area of any triangle. All right, before we get to the formula here, we'll come back to that in a second. We're going to try to do this one using what we know already. So I have a side angle, side triangle here, and I'm going to go ahead and sketch it. Remember, these are not drawn to scale. This is just kind of a general sketch I'm drawing here. So I have angle A, 57 degrees, side B is 30, and side C is 52. And I need to find the area of the triangle. All right, we know area of a triangle is 1/2 base times height. Which means I need to find a base, which you can use any side as a base. Let's say I want to use 30 as my base. And to use this formula, my height is a length, I guess I should say, that makes a right angle with my base, so an altitude of the triangle. So if I want to use 30 as the base, h would be drawn as such, something like this. If I can find h, I can plug in the formula and I'll have my area. Because it's an altitude, it forms a right triangle inside my larger triangle right here. And because it's a right triangle, you could use SOHCAHTOA ratios or you could use law of sines. I'm just going to use the SOHCAHTOA ratios. If 57 degrees is my angle of reference, h is opposite and 52 is the hypotenuse, which means I can use sine. Sine of 57 degrees equals h over 52. And then I'm going to go ahead and solve for h. And that just means multiplying by 52 on each side. Sine 57 times 52. and I'm going to get 43.6. I plug it in my area formula now. My base was 30. The height, the altitude that makes a right angle with that, is about 43.6, which that number I'm rounding to write down, but I've still got my calculator so I can use its exact value. That times 30 times 0.5, I'm going to get 654.16. This is an area, so I'm going to label it inches squared. Okay, so that is how we know how to find the area of a triangle. At the top, we have a shortcut formula for this. If you have two sides of a triangle and an angle between them, you can use this formula. This formula is written three different ways. It's kind of like the law of cosines we saw before, where all they're doing in each of the different forms is rearranging the letters. Typically, we use either the first one or the last one. Personally, I like the last one because it's ABC, everything's in order there. And we're going to use, instead of an A for area, we're going to use a K in this section because many times we're already going to have an A in the triangle and that could get confusing. We don't want it to look like an angle A. So we're going to say the area of a triangle K is 1/2 AB sine of C. And what that means is it's 1/2 times a side times a side times a sine of the angle between them. So let's see if we can use that on the triangle we just had a moment ago. My area is 1/2, and if you look at the given information, angle A is between side B and side C. So I can just fill it in. 52, 30, sine 57. So I'm going to go ahead and plug that in my calculator. And I get, what do you know, 654.16, and again I would label it inches squared. So you can see it's the exact same number, and it saves us all that work of having to calculate the height. If you look at the calculation, I've got a 1/2 and I've got a 30 in both of these. On the right side, I did 52 sine 57. And on this side, you can see that's actually the calculation that we did to solve for the height, 52 times sine 57. So somebody back in the day figured out, wait a second, if I have side angle side, I keep doing the same thing over and over again. I make my altitude, I use a sine ratio to solve for the opposite side, and that's my height, and then I plug it in the formula. So this is just a shortcut for kind of the long version that we did a minute ago. All right, moving on to the next problem. Let's say you're not given side angle side. Instead, you're giving either angle side angle or angle angle side. We can use a version of this formula. Let me sketch my triangle here. Side A, 16. Angle B, 57. Angle C, 49. In order to use that last formula, I need two sides and the angle between them, which I definitely don't have. So we're going to have to use law of sines or law of cosines to find what I'm missing. First thing I'm going to do is go ahead and just solve for that other angle. So 180, take away the 2 I have. I'm going to get 74 degrees. From there, I need to solve for one of the sides. It doesn't matter. Once I have one of the other sides, I'll have a side angle side in there somewhere I can use. So let's say I want to solve for side B. B is opposite 57. 74 is opposite 16. I have two pairs of opposites. That's the law of sines. Sine 57 over B. Sine 74 over 16. Cross multiply, I'll have 16 times sine 57, and then I would have to divide that by sine 74. And I get 13.96. Okay, so B is approximately 13.96. I'm keeping that number in my calculator. I don't want to round it in my calculator. I'm just going to use it in the next step. So now I have this kind of corner of my triangle filled out. I have a side angle side, which is enough to use that shortcut formula. So it's going to be 1/2 side, side, approximately, times the sine of the angle between them. So 1/2 times 16 times, in my calculator, instead of 13.96, I'm using the previous answer, times sine 49. And I get 84.28. And let's see, this was feet. So I'm going to label it feet squared. All right, moving on to the next example. Oh, this is one for you to try on your own. All right, go ahead and sketch the triangle and then solve to a point where you have side angle side. From there, use your formula. I'll give you a minute, pause the video. When you're ready, hit play. Okay, here's the correct answer for your practice problem. And I've written it 2 different ways depending on which side length you chose to solve for. So only one of these columns you probably need to be looking at, but you can see either way I get the exact same answer. And by the way, your answer should be exactly to this 100th place, because you shouldn't have to round. You could just use that previous answer in the calculator. So first thing I did, no matter what side you chose to solve for, everybody should have hopefully got that third angle of 78 degrees. And then from there, you either solved for side A or side C. If you solve for side A using law of sines, you get approximately 22.34, and then you use this corner of the triangle for your side angle side. If you solved for side C, you should have 24.31, and then you used this corner of your triangle to solve for the area. All right, so take a minute, check your answers, correct anything you need to here, and then when you're ready, let the video continue to play. We've got one last formula and example on the next page. All right, last but not least, we have one more formula for area of a triangle. It is Heron's formula. This formula is used for side, side, side conditions only. If you're given a side, side, side condition, you would have to solve for an angle to be able to give a side angle side, and that would be the more difficult version of law of cosines you would have to use. And then from there, you'd have to use the area formula that we've done already. Heron's formula is an alternative to that, and it requires not having to solve for any additional pieces of the triangle. You can see again, we have an area that they're going to use for a K. A, B, and C are going to be side lengths, and because it's a side, side, side triangle, you'll know all 3 of those. Those will be given pieces of information. So here, here, and here are all pieces of given information. You can see in the formula then, the only thing that you're going to actually have to find is S. S is 1/2 times the sum, times the sum of the sides, A plus B plus C, which if you think about what that represents, A plus B plus C, if I add up all the sides, is the perimeter, and then times 1/2 is half of the perimeter. So that's what, where it gets its name from, semi-perimeter. It's just a fancy way of saying half of the perimeter. So this S formula shouldn't be something you really have to memorize. You just have to remember that S is half of our perimeter. Once you have S, A, B, and C, you can plug them all in, put the whole thing in your calculator, and it spits out the area and saves us all that law of cosines work. So here's an example. A, B, C. A is 2, B is C, 3, C is 4. I can draw the triangle if I want to here, but I'm not solving for anything in the triangle, so I'm just going to go ahead and skip that step. First I'm going to find is S. S is 1/2 times all my sides added together, A plus B plus C. So that's 9 times 1/2, which is exactly 4.5. Nice and pretty number. From there, setting up my Heron's formula, square root of 4.5. And then these 3 parentheses, you can do them in any order. It's just semi-perimeter minus each of the sides. So -2, -3, -4. And then this whole thing you can type in your calculator all in one line. And then we'll round it and label it, of course. So big square root, 4.5 times 4.5 minus 2, 4.5 minus 3, and 4.5 minus 4. 2.9, and then we'll say, there wasn't a label on our original sides here, we'll just say unit square. Remember in the law of cosines unit, when we had 3 sides, it was sometimes the case where we did not have a triangle that was possible. And let me give you an example. Let's say A is still 2, B is still 3, but now C is 7. This does not meet the triangle inequality. The triangle inequality says that the 2 smaller sides need to add up to the larger side. So you could hopefully look at this, or add up to be larger than the larger side. I said that wrong. So you could look at this and say 2 plus 3 is not larger than 7, so there is no triangle possible. Let's say you don't notice that originally and you go ahead and start to use Heron's formula. Heron's formula, I would do first my semi-perimeter, which is 1/2, 2 plus 3 plus 7, which is 12 times 1/2, 6. Setting up my formula, I'm going to have 6 and then 6 minus each sideline. 6 minus 2, 6 minus 3, 6 minus 7. Here's what happens. I have a positive number, a positive number, a positive number, and then if I look at this last quantity here, when I try to do the semi-perimeter minus that big side length, it ends up being negative. So if I have a positive times a positive times a positive times a negative under that radical, I'm going to end up with a negative under the radical, and my calculator is going to tell me non-real solution or something like that. So this is kind of a giveaway. If you try to do Heron's formula and you get a negative underneath the square root, or your calculator is telling you that error, go back and look at those original side lengths and see if it passes our triangle inequality test. Again, 2 smaller sides need to be a sum larger than the third side. So maybe you can save yourself a little bit of work if you check that originally at the beginning, but Heron's formula will kind of reveal it in the process. All right, that is the end of the 7-3 video. Homework for this section is the 7-3 Math XL. This Math XL assignment is due on Thursday this week by midnight. Remember 7-1 part 1, 7-1 part 2, and 7-2 Math XLs are all due on Wednesday night. If you have not completed all of those yet, you want to go back and make sure you get those done for Wednesday. Tomorrow in class, let me know if you have any questions. You guys will have some time to work on those Math XL assignments.